Good morning. Let me first make a short introduction. My name is Klemens Waldhör and I'm professor, as you can see here, at the Hochschule for Oekonomie and Management. We are a private university and I'm teaching there computer science. And this is Mr. Waldhör. He is one of my bachelor students and he just finished some 2 or 3 months ago his bachelor thesis on this topic we will present to you now. I was here in Ljubljana 8 years ago. There was another conference, nothing to do with health in this case. It was about e-tourism. It was an inter-conference and I was giving a talk there about recommender engines using in tourism together with data mining. So this is now just for me a good reason to come back to me. Come back to here. It's not. Okay, so let's switch to that. Let's switch to our agenda. Okay, what we will talk about first, about motivation and problem. Why did we do this research? What is our key research question? Then I'll talk a little bit about the solution. Some of we have heard now Apple Watch. I will talk about a little bit Smartwatches, and then I will hand over to Robert, and he will tell you about the implementation he has done, or we have done. So you see it starts with ADL recognition, and hopefully maybe out there in the break we can give you also a demonstration of it works and how we can detect such drinking eggs. And yes, at the end I will give you a short summary. I started with the research in this area, which is normally called AEL, so Ambient Assisted Living, about 2 years before, together with another colleague. And our first idea was, how can we improve the life of elderly people? This was from my colleague's base. He had some private reasons why he wanted to do it, because of his father and so on. But you all know society gets elder and elder. We have, yes, things like Alzheimer and so on, which is getting more and more important for us today. And so the question is, how can we support elderly people, especially living at home, is a very important now. It will become even more important anymore. And you know, costs go up in the health industry and so on. It is not to say that there are no tools out there how you can support elderly people. You know, if you have parents or grandparents or so, there are things like this emergency call units that you have stationary at your home. If some emergency appears, you can call up Red Cross or whatever you want to do. Unfortunately, all these tools have one disadvantage: you have to make a lot of installations at your home. If it's internet-based or whatever, but you need a telephone or whatever, and the disadvantage is, if you don't wear this and you're not around your tool, you can't use it. So if an emergency accident happens, you may even, yes, lie on your floor and nobody comes and helps you. So it's expensive too. And another disadvantage is you cannot really analyze what's called ADLs, which is a specific term which means activity of daily life. What is an activity of daily life? I mean, it's drinking, it's eating, going to the toilet, making phone calls, reading your emails, everything you do, going out, walking around. So that's called an activity of daily life. With tools like this, you can't do this. I mean, okay, here you have to be active, push the button, and then you get some help, maybe. So we were looking for tools and gadgets, however you would like to call it, how we can support people in emergency situations. Our first impression, idea about 2 years ago, was using Google Glass. Unfortunately, for several reasons, Google Glass didn't work out. It would be an ideal tool, you know, legal reasons and so on. Okay, it didn't work out. So another point we saw is the stigmatization effect. There are special watches out there, not smartwatches, where you have here a big red button. And if you go out, everyone immediately would recognize, okay, this guy has some kind of impairment. Who wants this? Yeah. So we were looking for a tool which does not stigmatize you. And the other observation we made is that there are no real apps out there for this specific elderly target group. So our question was, and now let's go to the content of this talk here. Is it possible to detect drinking activities? I mean, not drinking alcohol and so on, beer and so on. Obviously, yeah, we can detect this too, but we cannot detect which kind of alcohol you are drinking. No, but drinking as an act, yeah. You may know drinking is a key health factor, not drinking much, what's the problem with elderly people is insufficient fluid intake. Will lead to several impairments like weakness, irritability, lack of concentration, and so on. Yeah, and especially if you're getting older and older, you lose this habit of drinking. Yeah, you do not feel thirst, and so you do not drink anymore. So that's really a problem for elderly people and also within. For doctors. So we thought, okay, I'll talk in a minute about smartwatches. Can we detect how many drinking intakes people are doing in a certain period of time? And the more general question was, if we can do this with drinking, can we also do it with other ADLs, like falling on the floor, which is also a bad thing for elderly people. You easily break your bones if you are elderly compared if you are 20 or something like that. This was the second question, and then my colleague will talk about this. Which parameters are sufficient to characterize such an ADL? Sorry, wrong key. So, our alternative, which we found about, let's say we started working on this about 1 year ago, is using smartwatches. I don't want to read now through all these features of the smartwatches. You know the iWatch, Apple Watch has given a really boost to this. Also, I have to say it's not really the best ones. Other smartwatches are much better, and it's just because it's Apple, it's so hyped. Anyway, what you see here is a Samsung Gear S running an application we have developed for elderly people. Give a short introduction afterwards. Yesterday in the user training you mentioned, okay, everybody is wearing a lot of different tools now. This tool is also sending data to the internet, connecting with the internet, and you could do everything there. As you see, okay, voice recognition with Google Now or whatever. So you could do everything in principle what you could do with your mobile phone. The drawback at the moment is that a lot of different operating systems used, like Android Wear, Swift, which is my Apple, Tizen, for example, from Samsung, WebOS. So a lot of new different operating systems now out. We wrote an application. And what we are talking about now is this detection of health hazard, which support especially people with what's called MCI, mild cognitive impairment. So this does not mean that you have Alzheimer, but sometimes you forget something. So we identified 4 dimensions. The first one is communication. So actually the smartwatch should be able, in case of an emergency, can make an automatic call to a Red Cross or whatever, to an emergency unit. Then orientation, especially for Alzheimer patients and their relatives. You have not to forget the relatives of these people. It's very sad if you have a relative and his, your man, your wife, your children, and then you immediately recognize he even doesn't know when is your birthday. What's the day today? So we identified this one dimension orientation, where we give information about, let's say, today is the birthday of your wife. So, I mean, if you look at it and it tells you, okay, then he knows something. The next one is localization, which means if you have Alzheimer, as an extreme example, I have to say, people do not really know where they are. So they tend to leave the places where they are at home or wherever they are, and then it's really difficult to find them. Smartwatches have GPS and things like that built into, so you can use those tools to find them. Yes, and the third one, the fourth dimension is detection of health hazards. In this case, the one we are demonstrating now is drinking detection, but also tumble, for example. Tumble is one of the really situation which happens to a lot of elderly people, and then they're lying around 2 or 3 hours in their home and nobody is coming to them to help them. Yes, and based on this, that's some kind of prediction is, can we detect deviations from daily activities? So if we recognize a person every day checks his emails, and now you recognize after some time he only checks it 1 per week, there may be something have happened to him. Yeah? So that's about detection of health hazards. Yes, just some slide how this looks like. So for example, okay, unfortunately that's in German, but this just tells this guy, okay, today is your birthday. I mean, if you have an MCI, you may forget about this. So it's ridiculous for us maybe, but for this person, he will forget it. Yes, there are some other one here. It says, okay, you have left your agreed environment, so please come back. Yes, and if you don't, we have implemented in such a way that you have to say, okay, I have read this, and it's no need to call the Red Cross. If you haven't read it after some seconds, okay, you get the information, an automatic call is executed. Yes, that's just some other ones. Yes, that's connected. If in case of a health hazard, yeah, you have not drunk for 10 hours, okay, you inform me it's now time to drink some water, for example. And if not, okay, maybe your children are informed about this. Yes, forget about this. This is just about the editor, how to use this service. So, as I said, we will talk about drinking recognition, and this was part of the bachelor thesis of Robert, and he will give you some information how you did it and how we use data mining for this.
Yeah, thank you. As Mr. Waldhör said before, I now would like to show you how we actually put the ADL recognition into practice. And basically, we used this process, including 4 steps. Well, first of all, it's data collection. We need to get some data before we can train the recognition. The second step is data preparation. We used a couple of filters and interpolation. I would go into detail one slide later. And then we performed the actual data mining in step 3. And finally, we used the parameters that were computed in the third step, and we will put them in a Java application for a smartwatch to perform an online activity recognition. So let's start with the first step, data collection. We used a smartwatch just like this one, and its sensors. First of all, an accelerometer, which you can use to measure acceleration of the device. Then a gyroscope that is used to measure the orientation. And finally, a magnetometer, which allows you to measure information about the magnetic field, the magnetic orientation of the device. And all of these sensors deliver 3 values in these 3 axes, as you can see in the picture. So we wrote a little Java application that runs on the smartwatch and allows you basically to record and also recognize activities and to distinguish between drinking and non-drinking activities. And as you can see in the picture in the bottom right, if you press record, you can also select which activity you want to record, and you will have the label that you selected just put into combination with the sensor values to keep track of what you recorded. So what did we actually record? One recording consists of a 10-second interval, and during these 10 seconds we measured about 1,800 sensor values. So this is one gesture that we detected, and it is saved on the smartwatch into a CSV file. And overall, we recorded around 1,200 of these gestures, and at least around 300 drinking activities and 900 other activities like walking around, different sports activities, brushing teeth, and a lot of different activities. And we used 28 different test subjects, so to prevent our model from being too focused on a single person or a small group of persons, we used 28 different test subjects for our recording. So as you can see in this box, this is one of our CSV files. The data will be stored in this format, and this, you can see the sensor values and also these shortcuts, WA, WG, and so on, which indicate the sensor that was used to store this value. Well, we used all of these 1,200 captured activities and performed a couple of filters on them using R, an R script, and we applied high and low pass filters to remove the frequencies from the sensor signals that we won't need for activity recognition. We also applied a median filter to remove outliers, and we used a spline interpolation to handle some problem with the sensors because they are not able to deliver time equidistant values. So the time spacing between two sensor value recordings is not equal. There's some small variance, and this could lead to problems with the signal processing and the training of the model. So we use this spline interpolation to correct this problem. Based on the filtered data, we performed a feature extraction. So we have 1,800 values per recording, but we want to reduce it to a small amount of features that give us a good representation of the signal. And we calculate 39 basic statistical features for each sensor, including like mean, standard deviation, and interquartile range, so basic statistical features. And we also transformed these sensor signals into the frequency domain using an FFT. And then we computed about 118 frequency-based features in addition. So all of these features were also computed in R, and we stored them into one big matrix consisting of all the activities we recorded and all of the features that were computed out of these recordings. So, in the next step, we applied different data mining techniques. First of all, we tried to cluster the activities that we recorded into two groups, like drinking and non-drinking activities, which was successfully done. And then we tried to train different supervised machine learning models like neural networks, random tree, random forest, and also logistic regression. And we were able to realize a good recognition rate. So we split it up in training set and test set, then trained our models on the training set and made predictions for the test set. We also checked it with cross-validation. And basically we focused on two algorithms, logistic regression and neural networks, as you can see in the graphics. The recognition rate and the precision of the recognition is quite solid, but for our real-time recognition, we decided to use the logistic regression, even though it's not as precise as the neural network, because it's just easier to compute the logistic regression on the smartwatch, and the parameters, the weights, are easier to put into an application. So, and that's the real-time activity recognition process that we are using. Basically, it's a continuous recording of sensor data. So we had a 10-second interval when we first recorded our activities, and now we have it split up in these 5-second intervals, and we always combine two of them to one activity. So by doing this, we create a small overlap so that we can capture activities that are in between two of the recordings. And for every 10-second activity, we perform the same digital signal processing as we did before, filters and interpolation. And we also extract features, but this time we only use the time domain features. We not use the FFT because the computation is a bit too much for the CPU of the smartwatch, so we just use these time domain features. And then we create a prediction based on the model that we trained before. But for training, we also use only the time domain features. So it's just without the FFT features that I've shown you in the previous slide. And as a result, our app will show us, just like you can see in the bottom, if it's a drinking activity or if it's not a drinking activity. And overall, the classification of drinking activities is pretty good. We receive a high precision, but we have still some issues with the non-drinking activities. There are a lot, like 16% in the test that we had, which are false positives, and this might be due to some issues with the filter implementation of the smartwatch. There's still some struggle, but overall, most activities, if you put it into practice, are recognized correctly. And yeah, that's basically our implementation that we've done. And I think Mr. Waldhör wants to continue with a few other points.
Yeah. Okay, so you see, I mean, by the way, we used R because I'm teaching also R at the university in statistics, so that's the reason using R. And as you can see, it works quite well. Originally, when Robert came up and told me he wants to try it in this way, I have to be, I was a little bit skeptical. My original thinking was in another way. My original thinking was, okay, we analyze the physical movements you do in the x-axis, develop a physical model, and based on this, compare it against the sensor values. So not, let's say, data-based, just really a model-based approach. And so I was surprised, but also quite happy that it really worked out such well, and so that it's a nice example of using data mining in this area. We have implemented this also in our smartwatches. I have several of this, so this is one, the Gear S, and I have also Android Wear, and Robert has also a smartwatch with him, and maybe if you like, we can show you later on if it really works. I mean, there are still some obstacles in it, like, okay, you know, a smartwatch is not very fast. Yeah, it's not really built for a huge number crunching, stuff like this. So the way here you see some state process machine, how we implemented this or is planned to run it on this Gear S. Obviously, if you detect somebody is not drinking for 1 hour, you will not call an emergency company, yeah, or your relatives. I mean, okay, there could be several reasons why you do it. So a key fact is, if we recognize such a health hazard, we ask people, okay, are you really in a hazardous situation? And then he has a freedom to decide yes or no. Only if he doesn't react within a certain period of time, 10, 15 seconds or so, we automatically call an, let's say, for example, Red Cross, Johanniter, or whatever they are called here in Germany. So that's just a model. The user has to be integrated into this, so no fully automatic actions to be done. Yes, here you see, for example, such a scenario. It tells the user, Gerhard in this case, you have not drunk anything for a long time, please do drink something now. Yes, and if he doesn't really respond to this in the next minute or so, it could mean that he has fallen down or whatever, lying in his bed and not is heavily ill or something like that. Then the emergency call action will happen, either children or whatever emergency organization is behind it. Yesterday we learned, okay, that data mining is not just on your local PC, on your local environment. You have to integrate it into a greater environment, and so that's an environment we are currently working on it. So on the top you see the smartwatch with the app running. Here on the left you see the home emergency call center. Something standards, I think most countries worldwide have this now, which is connected by the internet through the watch, and if something bad happens, okay, they receive information like, okay, where did it happen, GPS information, what happened, and so on. And on the other side, this is long-term analysis, this is what I said before. We do not only want to detect actual problems, but we want also to detect problems which just arise over time. And so that's what this server is intended to be used for. What are the problems with this? Okay, I don't know, who of you has a smartwatch? One of the key problems of smartwatches is energy management, batteries. So, I mean, in reality, smartwatches are not watches because after 24 hours, they have no power anymore. If you would sell a watch with this time, you would say this is not really a watch. So that's one of the real big problems. And if you are running this drinking detection, I have recognized, okay, this needs a lot of computational power. So the basic idea we have now is, let's move the actual computation to a server. So let's say in some time interval, 5 minutes or so, the sensor data are sent over to the server, and each hour, for example, the server makes an analysis. It depends, obviously, on the type of hazard. Drinking is not so important as if I go here and fall down. I have to recognize this immediately. So that's one thing. This will also will help to save battery power. The next thing is obviously, with data mining in general, I think, is ethical and legal questions. So are you really allowed to gather this data and send it to some server out there? Who has access there? Especially with people like with MCI or Alzheimer who really do not know what they are doing. How can they sign something like that? So that's a legal question which we are also investigating now. And then, as I said, battery management. Most people do not like to wear watches when they are sleeping. So how do I detect health hazards in this case? So this may require integration with house automation, for example. Yes, and next thing is also medical device certification. If you give such an advice, I mean, drinking is obviously a border, but if you say, take this or that drug, that is really a problem. If it's a wrong drug, he takes a wrong drug, and then you are, as a producer of the software, okay, who is really responsible? So that's also a problem. Yes, and what we are doing now, for example, in Frankfurt and so on, we are running some tests with such systems together with the Red Cross. To summarize, what I think we could show is that smartwatches like this can detect ADLs. They are accepted by elderly. The real advantage of a smartwatch compared to this red button big thing I talked before is that people know what a watch is, and this looks much more like a watch and is not so discriminating. So the father of my colleague, he was really happy to have this. Also, yeah, he had some MCE and he accepted it. So this type of gadget or electronic device is also accepted by them. So what we want to do next is to try to detect different ADLs. Maybe also one idea we have, can we detect based on the signal how much you are drinking? At the moment we just can say you are drinking, let's say 10 drinking acts per hour. It would be much more, for medical purposes, for example, interesting to know, okay, I know you have drinking 1 liter in this hour, in 1 hour. So that's one thing we are currently looking for, but it's, to be honest, it's much more complicated. It depends if you're using a glass, a cup of coffee or whatever. So that's really a tough stuff. Yes, and based on this, we can do some daily report generations for your children or whatever. Yes, and detect tumbles, for example, or toothbrushing, which is also very important. So it's a key fact. If people forget about toothbrushing, this could mean that something bad happened to their mind. So that's also a very good indicator. If I can detect he's not toothbrushing anymore, okay, please do something, go to the doctor or whatever. Yes, and finally, what we also want to do, you know, smartwatches are not very big. You have only a small screen. We're looking how do we optimize the user interface for this. Okay, so thanks for your interest. By the way, we are running a conference, especially on health informatics next year. So if you're interested, and we are looking also for topics with data mining in this context. So if you have interesting applications in this area, just go to our website and look at it. Maybe you can send us an interesting paper on this. Okay, thank you very much.